Alright, so for this question, a satellite is in orbit around the center of the Earth at a height of 16,000 kilometers above its surface. The satellite completes one rotation of the Earth in 7 hours, and the radius of the Earth is 6.4 times 10 to the power of 6 meters. Calculate the average speed of the satellite. So to begin with, let's again write the facts down. So we always like to start there. So first of all, I've got my fact over here. Height is 16 kilometers above its surface. Now, before actually with this sort of question, I would actually like to draw a diagram. If it's a little bit complicated, if it's not straightforward, I would like to draw a diagram. So let's start with the Earth. Right, that's the Earth. Write that down if you want. Now, there's obviously a satellite rotating around the Earth, obviously, hopefully smaller than the Earth, a little bit smaller. Just going to write satellite. Alright, brilliant. So now I've got to fill in the gaps. So, let's have a look. So here we go. Height of 16,000 kilometers above its surface of the Earth. So that means from the surface of the Earth to the satellite, that is 16,000 kilometers. The satellite completes blah, 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 and here we go, here's another fact. Radius of the Earth is 6.4 times 10 to the power of 6, meaning, I'll just do it with a different colour pen, so you can see. So from here to here is 6.4 times 10 to the power of 6 meters. Now, if we want to add these two together to find the final length, which is this length, we need to kind of make sure they're in the right units. So I'm going to maybe change this one to the right units, which is meters. So 16 is 1,000, and then 10 to the power of 3 replaces the 10, replaces the K. So if you have a look at your prefixes, so K is 10 to the power of 3. It just kind of replaces it. It substitutes it basically. So K has a value of 10 to the power of 3. Alright, brilliant. So my whole, length, this one over here, if I calculate that, it's just, so let's call that, radius, because that's the radius of the satellite rotating. That is going to be 16,000 times 10 to the power of 3 plus 6.4 times 10 to the power of 6 meters. So that's the radius, and you can do it. I'm not going to bother doing it just yet and putting it probably in like that. Alright, so now we've got to figure out what's happening. So we've got a time value. So I'll write that one down in my facts. So my time is 7.4 hours. I might change that into seconds because that's the standard unit. So that will be times in minutes. So hours into minutes, that's 60 minutes per hour, and then minutes to seconds, that's hopefully 60 seconds per minute. So that will be in seconds now. Alrighty. So that's my time. It says calculate the average speed of the satellite. So what we're trying to find is the V. Hopefully we understand that. Now with this over here, we're not quite done yet because it says satellite completes one rotation of the Earth. So you actually have to read what kind of the context of the problem. You can't just, write any numbers in for your S, because obviously S as a displacement is what we need. So what basically this question is saying is, I'm just going to use this marker, for the satellite to be kind of rotating around, like this, for it to do one rotation, it takes 7.4 hours. Here you go. And so the distance traveled is actually that circumference of that circle. So obviously we've already figured out that radius value. So all you have to do is figure out the circumference, which hopefully you understand. The circumference of a circle is 2 pi r. So in my radius, we've already found over up the top. So all I have to do is substitute, 2 pi and the radius of that massive number over here. Alright, so that pretty much becomes my S. I know it's the circumference, but that is the distance traveled in this specific example. So I'm just going to copy it down here. Now, I know it's a lot to write, so if you don't want to keep writing, you are more than welcome to evaluate that first and have it as like one answer, but I can't be bothered. I don't have a calculator right in front of me, so I'll write it as that. Now, my V is going to run out of a bit of space, so my V is going to be S over T. Oh, let me maybe write it like this. So my S is, that big thing we wrote. There we go. My T is 7.4 times 60 times 60, and hopefully if you chuck that in the calculator, making sure you've got all the right answers there. Let me just quickly check. That should hopefully give you 5.3 times 10 to the power of 3. And because it's of speed, it's a velocity, it's going to be meters per second. So hopefully that's the answer you got.